All right, now we're moving on to some kinetics problems. So for the reaction that we have here, we have two ammonias decomposing to give us N2 plus 3H2. And we can write what's called the rate equality for this. And this is always the first step for this sort of problem. Rate is equal to, and for any reactant, it's a minus sign, minus 1/2 the change in NH3 over the change in time. Okay, the minus 1/2 because it's the reactant, and the reactant is being depleted. And then for every product, so we can say that this is 1/1, or we can say that it's 1, or we don't have to put anything. We'll just say that it's 1. The change in the concentration of N2 over the change in time. And then finally, this one is a little more interesting. 1/3 the change in H2 over the change in time. Okay, so, and then we have to decode what's given to us in the problem. So the problem tells us the rate of formation of H2 is 6.0 molarity per minute. So it is this part. So it's what the problem has told me is delta H2 delta T is equal to 6.0 molarity per minute. Okay, so it's given me this piece. Not this whole thing, just this piece. And so we have a whole set of equalities here. So this is a situation where we have something like A equals B equals C equals D. And so anything inside there is also equal. So since I said all four of these is equal, also this one is equal to that one, and this one is equal to that one. So that's what we'll have to play around with a little bit here to work this problem. Okay, well the first one asks then what is the rate of N2 formation? So I'll just take this part of the equality here and rewrite it. Okay, the problem gave me this piece. So 1/3 6.0 molarity per minute. Okay, I just put this in for this value that it gave me. And I made all these so the numbers, I could do them really easily in my head. So 6 divided by 3 gives me the rate for this one is equal to 2.0 molarity per minute. All right, what else does it ask me? What's the rate of NH3 decomposition? So I'll again just rewrite that part of the problem. Minus 1/2 delta NH3 delta T is equal to 1/3 delta H2 delta T. So I want to solve now just for this piece of it. So I'm going to multiply both sides by -2. Delta NH3 delta T is equal to -2/3 delta H2 delta T. And again, the number was given to me up there in the problem. So -2/3 of 6. Okay, and that'll give me 4 -4 molarity per minute. So the concentration of the NH3 is decreasing by -4 molarity per minute. And then finally, this problem asks us what is the rate of the reaction. And so all these concentration changes relate back to the rate of the reaction. So I'll rewrite just that part. Rate equals 1/3 delta H2 delta T equals 1/3 of 6 molarity per minute equals 2 molarity per minute.